Okay guys, so this is a tutorial for React Native Flexbox design. So if you are a beginner like me, where you know how to run projects, start projects in React Native, but when it comes to placing things in the UI aesthetically, you have a hard time and you're struggling, you're getting frustrated because you try moving the objects, but the objects are not moving the way you think. If you are like that, then this video is for you. This is a beginner tutorial for mastering this section, layout with Flexbox, of the React Native documentation. But personally, I've had a lot of pain going through this documentation. And the reason is, say you want to learn this topic align items. Now, the demo for align items is superb actually. You can easily see what's going on and what align items does. Start, end, center, baseline, stretch, you get the idea. But when you want to grab the code of align items, that's where it gets problematic. So in this complicated code of 100 lines, somewhere in between here, label selected value. So just delete that and say align items equal to flex start. There, we got the behavior. So change the values like center, flex end, and now we have a playground that we actually understand. So they have given you a playground that you can't actually play around with. So in the beginning, I struggled so much and I painfully sat and read through all these 100 lines of code to figure out this one line of code that I need to play around with. And understanding the code is also really painful because if you look at align items playground, you will find FlexWrap there, and FlexWrap is like 4 chapters down the line. And what's more, if you want to understand align content, the very next chapter, this says it works only when FlexWrap is used, and FlexWrap is the next chapter. So even though these contents are arranged in this linear fashion, the tutorial can't actually be read in a linear fashion. You'll have to go crazy and go up, down like a compiler, where the styles that are used here are actually at the bottom. That's how they have made the tutorial also. Basically, they are assuming you are a compiler. But in this guide, I'm assuming you're a human like me, and I'm trying to remove the pain that I suffered through when I was going through this tutorial. So before learning Flexbox, let's first learn the default behavior of any box. So there is view and text. Let's play around with that. So let me get some text on the screen. Text 1, text 2. So they are like very small. Let's give it some font height. Okay, so that's better. And let me give some background colors. Let me grab this powder blue and steel blue. So we have our 2 text elements. But what we need to notice is, in React Native, basically everything is a rectangle. So if this is your phone, then either the rectangles can be arranged row wise or column wise. And if you take any rectangle, so you will have a width and a height. So this is your phone, and these are the rectangles inside the phone that we are designing. So width, height, and placement of the rectangle. This is what Flexbox is all about. So if we go back to our code and give default width and heights, width 100, height 100, same thing for the other one. So these are our rectangles. But when we don't explicitly give the width and height, look at what the default behavior by React Native is. So if you have a bigger phone like say iPad, then width will be the phone size here and width will be the iPad size here. And if you look at the height, well, the height is determined by font size. So if I just remove the text and make the font size 100, then the element size is 100 now. So width, height is done, and if you look at the placement is basically arranged in the vertical direction. So if we summarize, the width is maximum width possible, height is height of the content inside, and placement is vertical. This is the default behavior of text elements. If you look at view, same thing, little bit difference. So let me add some views here. Let's go back to 30. So I have 2 views here and basically two text elements within each view. Let me give a default height and width first, width 100 or something like that. So I've given width and height as 100, 100 for both the views. So basically even the views are like boxes, like how we previously saw, and the placement is vertical, and width and height I have set it, but if you don't explicitly set it, then the default behavior is same thing. Width is maximum width possible, height is determined by the number of contents inside, and placement is vertical. And if you explore the height part, so if I just remove all these texts, then height of this view is basically 0, and I can show you that. So let's add a border 5 and border color black. You see that? That's the view. Basically the view's height became 0. So the height is always dependent by the contents inside, but width is never dependent on the content, it's dependent on the phone, and it takes the maximum width possible. And if you see, both views and text are like behaving the same way. They're basically rectangles, and we need to figure out what is the width, what is the height, and where is the placement. And if you look at the Flexbox concepts, then this behavior can be mimicked using flex, flex direction, and align items. So if I give flex as 0, flex direction as column, and align items as stretch, then this is the behavior that we will get for both text and views. So basically every element in React Native is having these 3 values by default. So you are actually using Flexbox without even realizing it. So every element that you can think of, views, text, touchable opacity, everything by default comes with these 3 values. And you know what these 3 values determine: width, height, and placement. We'll go deeper into that. But the most important thing to understand is, since we can keep on nesting, meaning I can have a view inside a view inside a view, like I can keep on going infinitely, like Inception, dream within a dream within a dream. Similarly, your entire mobile application is basically a big box, that is the phone, within a box, within a box, within a box, within a box. So I have drawn something shabby here, but you can clearly imagine like an application where you have a box, and within these boxes there are like 2 pillars, and within these 2 pillars they are arranged vertically here, horizontally here, so on and so forth. And in this nesting of boxes, what we need to understand is the relationship between every box has a parent, grandparent, and ancestors, and every box has children, grandchildren, and so on and so forth. So the only thing that you need to understand is the relationship between a parent and his child. If you understand that, if you understand the relationship between parent and child, then you can go along any depth of this nesting and understand what is happening. So in any complicated app, a view that is deeply nested somewhere deep within, even there you will understand what behavior it will exhibit, and you will be able to do precise aesthetic designing. So let's start with something simple where we have only one view and 2 text elements inside. So one parent, 2 children. So let's first give them some width and height. So width, let's say 400, and height 400, and for the children we can have 100, 100. Now in order to visualize the view, let me add a border. So this is our parent and these are our children. Now every rectangle has 2 axes, the x-axis and the y-axis. So if we take this as our phone, and let's say there is a view here, the parent view, and it has 2 axes, the x-axis, y-axis, and you can set one of these axes to be your main axis. So if you set x to be your main axis, then y becomes your cross axis. And instead if you set y to be main, then x becomes cross. And what is the use of setting a particular axis as main and the other one as cross? Well, when parent sets x as to be the main, then all the children will get arranged along the main axis, in this case x. And if suddenly the parent changes its main axis to be y, then all the children now get arranged along the y-axis. So the main axis of the parent determines the placement of the children. And how do you set the main axis? Well, basically you say flex direction is equal to rho, meaning x-axis is going to be your main axis, and therefore the children are going to get arranged along the x-axis. Similarly, when I say main axis is column, then they are arranged along the y-axis. But after getting arranged along the main axis, you can see that there is some empty space here. So if I change the height of these text boxes, say 200, 200, then they perfectly fit the parent, which is 400. And there are only 3 combinations that can come here. You can either perfectly fit it, or underfit it, or overfit it. It's like going to a party. You can either go late, on time, or early. And when you underfit and create this empty space, then the parent gets to decide how this empty space is organized. So if I say in the parent, justify content center, then the empty space is split into half and is placed on either side of the children. Now if I explore all the other options, then flex start, flex end, space around, between, evenly, you can keep playing around with the various options and figure it out for yourself. But the main thing to understand is, if the children overflow, then the justify content is useless. Justify content is no longer justified. So remember, only when the children underflow, the parent can control the empty space. And we have seen the empty space, okay, let me correct it back. We have seen the empty space along the main axis, but what about the x-axis, meaning the cross axis? So there is another term called AlignItems, which controls the cross axis. And if I say center, then the same thing happens. where the empty space is organized with different options. So there is flex start, flex end, and the final option stretch. Well, if I say stretch, nothing happens. And the reason is because we have fixed our width to be 100 in our children. Now if I remove this, then the parent starts to control the children and it stretches them. Now if I simply flip the main axis to be row, then what do you think will happen? Well, basically main axis is row, so the children will get first arranged in the along the main axis, and then I have stretch in the cross axis, and then I have center along the main axis. So if I say save, stretch didn't work because the height is now fixed. So how these two commands work depends on the first command, which is setting the main axis. So justify content is for the main axis and align items is for the cross axis. And you must always check how the axis is being set. But along the cross axis, the children have a new power which is called AlignSelf. So if I say AlignSelf center to the first guy, then he can override the command given by the parent. And this is possible only in the cross axis. Meaning only in the cross axis, the children can override what the parent says. So there is only justify content, align items and align self, and there is no justify self. So how do the children control the empty space in the main axis? Well, they control it using flex. So our main axis row here, let me first make it center. So all the empty space has been equally divided and put on either side. Now if the first text box says flex 1, then it basically stretches, meaning flex means flexible, and completely consumes all the empty space that is left in the main axis, which is exactly what the children were doing using aligned self. I mean, here we can do just stretch. I know this is confusing, but to summarize, if this is your parent, and let's say I set the main axis to be x-axis, and let's say these are our children, then these empty spaces can be controlled by the parent using justify content, but it can be controlled by the children using flex. And this empty space along the cross axis can be controlled by the parent using align items, and this empty space can be controlled by the children using align self. So if I say align items to be stretch, then all the children will stretch and fully cover the y-axis, in this case the cross axis. But if I say flex as 1, that makes this box stretch fully and cover the empty space along the main axis. But what is this 1, 2, 3 funny business with the flex? I mean, in align items it was all very clear, right? Stretch. Well, the 1 stands for voting. So let me first make this center and remove align self so that it's clear. So let me remove flex because even I am confused now. So flex direction, and let me make this start. So flex direction is row and justify content is start. So all the empty space is in the end. Align items is in the center. Okay, cool. Now let's say this text box says flex 1, then it fully consumes the empty space. But let's say the other child says flex 2, then the empty space is split in the ratio of 2:1. So to be clear, if child 1 says flex is 2, child 2 says flex is 3, child 3 says flex is 4, then what React does is, it sums up these numbers, so 2 plus 3, 5, 9, divides every number by 9 and multiplies this fraction with the empty space. So 2/9 of the empty space is given to the first child, 3/9 of the empty space is given to the second child, and 4/9 is given to the third child. So basically the children can now fight for the real estate. Let's say we have 3 children, and if they say 1, 1, 1, then they are all going to get it equally. If one guy is like 100, then he is going to dominate the others. So if I get it back to 1, 1, 1, then this looks good. So basically, to recap, this is the phone, this is the parent, and we have set x-axis to be main, we have the children, and then we have the empty space. Empty space is controlled by the parent using justify content, controlled by the children using flex. Empty space along the cross axis, controlled by the parent using align items, controlled by the children using align self. But why the difference? I mean, here we are rationing using 1, 2, 3, there is a voting system, there is division and lots of arithmetics. But in align items, everything is simple, there is just one single word, stretch. No business of stretch 3/4 or 4/4 or 9/4. That is number 1 difference. And number 2 difference is align items and align self are similarly named, but justify content and flex are not similarly named. I mean, a simpler thing would be just justify content, justify self, and make everything same. Why so much drama and complication, right? Well, the reason for that is, let's remove all these things and just have flex direction row And let's focus only on the main axis, and let's now add lots and lots of boxes. So it's completely overflowing, but you see there is a lot of space in the parent. So why not use up all this space? Why not make the text elements come down here? So that is the thing about main axis. So if I have a parent, and this is the phone, when I choose main axis as X, and if I populate children, all of them are populated only in the first single row. So the children keep getting populated, and then they just overflow the phone and they become invisible here or here because this is the size of the parent. They never come down, they never wrap and come down and populate this area. So this area is always going to be free, and therefore the individual children can choose, dominate and do align self and all such things. So along cross axis, you have extra freedom, more simpler choices like align self. But along the main axis, all these children have to fight with each other for the space, and therefore the voting system called flex. Flex 4, flex 5 means 4/9, 5/9 empty space is given to these children because these children are fighting for space along the x-axis, but the y-axis is always free because the children are always arranged along the main axis in only the first row. They never come to the second row, never come to the third row. All the fight happens within the same row. So they fight saying flex 1, flex 2, flex 3. But along the cross axis, they get independence. Each guy is like align self. I'll go here, I'll go center, I'll go end, anything. And that's the design that React has chosen. But that all breaks when you do flex wrap. So when you say flex wrap, all these children will wrap around and occupy the spaces in the cross axis also. So this will stop happening, and these objects will now start populating along the y-axis when they're running out of space. So this is flex wrap. And when you do flex wrap, then all the freedom of align items and align self is no longer valid. So if I have flex wrap here, so let's make this flex end align items, and I have some align self for this guy which says flex start. So they are all enjoying this freedom along the cross axis because the objects are never wrapping around. But let's say I say wrap, flex wrap. Now all the align items, align self, everything becomes invalid. It's as if we deleted these commands. So if we delete these commands, and if we have flex direction row and flex wrap, then they are no longer overflowing, but they're wrapping around and they're arranging themselves along the cross axis. So when they arrange themselves along the cross axis also, then that freedom of mobility is lost. Align self, the children can no longer do, and align items also becomes invalid. So align items and align self pair becomes invalid when you start wrapping around. And when you don't have wrap, everything gets jam packed into that same single first row. And if it can't be packed, they just overflow, go out of the screen and they are not visible. Now before we go into the more complex flex basis, grow and shrink, we need to understand flex first. So let's reduce some of the boxes. So let me start with these 3 text boxes where flex direction is row. So this is the main axis. You have align items flex start, so they're all placed up here. Now let's focus only on the main axis. Say I make text 1 width to be 200, text 2 to be 100. Total is 400, right, parent? So we have already used 300. And let's say the last guy is width 50. So there is remaining 50 empty space along the main axis. Now when I say flex 1, then this is going to override this width value, and text 3 is going to take up all the space. Now since flex is overriding the width value, let's remove the width value since it's confusing. But what if text 1 and text 2 together take up all the space, 200, 200, so total 400. They eat up the parent completely. So there is no empty space along the main axis. And text 3, well, that its width is set by flex 1. So how much width will text 3 get? Well, if I save, text 3 disappears. So basically all the non-flex boxes, basically boxes which have a width or content inside, all these boxes after taking up the space along the main axis, whatever empty space is remaining, that is being eaten up by the flex boxes. So since text 1 and text 2, that 200, 200 completely ate up the 400 space, there was no empty space for text 3, which was a flex box. So if you have non-flex boxes and flex boxes together in the main axis, then you need to sum up all the non-flex boxes, subtract them from the total parent's width so that we get the empty space, and that empty space is now ration among all the flex boxes with all the arithmetics. So if I have 3 more boxes, text 3, text 4, text 5, all of them are flex, but these 2 are non-flex and their width is like 100, 100. So they both together have eaten up 200 space. So the remaining is 200, and that 200 is shared between all these 3 flex boxes equally. So this is 200 and this is 200. So if your flex boxes suddenly vanish in your design, then you know why. But what if I switch on FlexWrap and I give this 200 and 250? That means together 450 cannot be on the same line, it will overflow. So 200 will get arranged here, 250 will get arranged in the next line, and these three boxes will now calculate the empty space in the next line and split them equally. So always arrange the non-flex boxes. If there is flex wrap, then wrap it and arrange them. Then in the final row, whatever empty space is there along the main axis, that gets rationed among the flex boxes. So if I have this one as 350, then in the tiny 50, three text boxes are going to flexibly shrink. So this brings to my main point, which is when you set a box to be flex, it can both shrink as well as expand, depending upon how much empty space is there and how it's rationed among other flex objects. So why I'm stressing this point is, if we go to flex basis, grow and shrink, well here the growing part of the flex boxes and the shrinking part of the flex boxes and the default width of the flex boxes can all be individually controlled. So you get more finer control when you go to flex basis, grow and shrink. So let me get that. But before that, let me show you some bugs which will help us gain a deeper understanding into Flexbox, because whenever you work in Flexbox, I have often found that I get these irritating, frustrating bugs and I never know what's the problem. I'll show you one example. So let's say I have these two text boxes and we have parent size, flex direction, column. Now when I do row, the boxes disappear, but when I say column, the boxes appear. What's going on here? Well, basically, let's consider the two scenarios. So this is the phone, this is the parent. Now in one, the main axis is column, in the other main axis is row. So our two text boxes, we need to consider their width, height and placement. Now since this is column, they are going to get arranged along the column, and since this is row, they are going to get arranged along the row. Now I told you every single box or every element in React Native has default values. So we have align items as stretch and flex as 0. These two properties are set both for the parent as well as the children. So since align items is stretch in the parent in both cases, these boxes are going to stretch along the cross axis. But since flex is equal to 0 is set in all the text boxes, along the main axis, in this case, the text boxes are not going to expand and cover this empty space. And in this case, along the main axis, these text boxes are not going to expand and cover this empty space. So this is not going to happen and this is not going to happen. So if you take the width and height of the boxes in both scenarios, due to align items equal to stretch, in this case, the width is maximum width, and in this case, the height is maximum height. So the same command, but depending on the flex direction or the main axis chosen, here it controls the width of the children, here it controls the height of the children. And flex, which was supposed to control the height and the width in these two cases, is set to 0. So these are not flexible boxes that are going to fill up the empty space, and instead are going to look at the contents inside the box in order to figure out its width or height. So what is the height? Well, I have specified in the code that font size is 30. So height is 30. But what is the width? Well, in our code, these text boxes have 0 contents inside. So our width is 0, which is why when flex direction is set to row, boxes disappear. But when it's set to column, the boxes appear. So this is row and this is column. So in order to make them appear in row, we need to either give hi and bye or say flex is 1. So this is how you debug bugs in Flexbox. You need to always remember the default values which are applied to every box in React Native, including the phone right here. I mean, for the phone, the width and height are fixed. It's the phone that you bought. But flex direction is always column. That's where you begin. Which is why when you take a phone, since width, height, and flex direction is set, so align items is stretch even for the phone. So when I add an empty view, and since flex direction is column, align items is going to affect the cross axis, and the view is going to by default get maximum phone width. Let me give you another bug. So now that our boxes are visible, let me do flex 1. Let me remove this. So in column they appear, in row they disappear. But when it's appearing in column, if I say flex wrap as wrap, the boxes disappear. If I say no wrap, they appear. How does this bug work? So in this flex direction equal to column case, this case, when I add flex wrap as wrap, they disappear. If I say no wrap, they appear. And the reason for that is, as I explained here, when you say FlexWrap, AlignItems and AlignSelf stop working. So when we go back to this problem, AlignItem stretch stops working when FlexWrap is set to wrap. So what happens to the width? It's no longer maximum. It depends on the contents inside. And since there is no content inside, the width is 0 and they disappear. Now, like in previous example, adding flex equal to 1 won't solve the problem, because flex 1 is going to expand these boxes only along the height. So flex is only going to change the height. Width is still set by the contents inside. So this is a second bug. Let's go to the third bug. Third bug is, let's say I give some content inside. Hi, bye, and I give flex is equal to 1. I change this to row. I remove FlexWrap and I remove the size of the parent. So the boxes are appearing here. So it's just simple view. Flex direction is row. We have a high, by, width and height all properly defined. And if I simply say column, they disappear. Row, they appear. Column, they disappear. So what's happening here? Again, two scenarios. And we have the parent view, text boxes and the phone to consider this time to understand what is happening. So since I have not given any size to the view, we need to also consider the width, height and placement of the parent view. So the phone has a fixed width, height. Phone's flex direction is column. So the view is going to be placed along the column. Let me write that down. The phone also has AlignItems stretch, and phone's flex value we don't have to bother. So AlignItem stretch, that means along the cross axis of the phone, all the elements are going to stretch. This is the view. View's width is going to be phone's width, but view's height depends on the content inside. In this scenario also, the phone has the exact same values, so the view has the exact same properties. So this is our view's width and height. Now when we consider the two scenarios where the parent view has flex direction column and row, so in this case inside the parent, flex direction is along the column, and in this case flex direction is along the row inside the parent view. So text boxes are going to get aligned this way, and here this way and this way. The text boxes have a content inside, hi, by, so that gives us the width. It also has font size defined, so that gives us the height, but it also has flex equal to 1 defined inside it. So previously AlignItems was stretch and flex was 0, but here we are defining or forcing the flex to be 1. So if we look at AlignItem stretch that is defined in the parent view, that's going to make these boxes stretch along the cross axis. So it's going to stretch along the cross axis, stretch along the cross axis. But if you look at the parent view size, only the width is defined, but the height is not defined. So in this case, the text boxes are going to get maximum font width, but in this case, it depends on the contents inside. Basically, height is going to be font size, and here width is going to be font width. And since flex is equal to 1, here the boxes are going to expand along this way to cover any empty spaces, and here it's going to expand along this way to cover this empty space. Again, in the parent, height is not defined, but width is defined. So the width of the parent is defined, so this width is defined, this is the empty space, and this is relation between the objects. And so when we say flex direction is equal to row, we get this behavior where height is font size and width is font width. Height is font size, width is font width by 2. But in the other scenario, the children's height is going to expand to cover the parent's height, but the parent's height is defined by the children's height, because for the parent, the content inside is basically the children. So it's a deadlock. The parent is saying my height is dependent on the children inside me, and the children, by saying flex is equal to 1, they are saying my height is defined by the parent that I am sitting under. So parent is dependent on the child and child is dependent on the parent, and nobody is setting their height in a clear way. So we get a deadlock where the boxes just simply vanish. Column, if I say. So these are our 3 bugs, and when you work on your project, you will get a million bugs, and everywhere the solution is the same. You have to reason from first principles. You will have to consider the font's width, height and flex direction, every parent, every child, every grandparent, every grandchild, width, height, how their dependence works, are there any deadlocks, and you must consider these default values: AlignItem stretch, flex is equal to 0, flex direction is equal to column, which are applied to every single element, including the parent, grandparent, grandchildren and grandchild. So this is how complex Flexbox is. So don't get frustrated with it. Sit and analyze with pen and paper. What is the width, height, placement of every single box? Everything is just a box. Everything is just a rectangle, including your phone. So reason from first principles and crack and debug all of your problems. Now, one last thing that I failed to discuss is FlexWrap. So if I say FlexWrap, AlignItems is going to stop working, so it's not going to stretch. So let's say wrap. And if I add lots and lots of boxes, they're going to overflow neatly. And now if I say gap is equal to 2, there'll be this gap here. So if I say 10, you can see the gaps. Or you can say row gap, which will only specify the gap in the row. So okay, between the two rows. Or you can say column gap, between the columns. So that is this portion that is covered, row gap, column gap, and gap. So if I remove this now, I want to teach you align content, which is sounding just like justify content. Can you see the similarity? So let's try it and I'll show you. So if I say align content is equal to center, the two rows of boxes come to the center. If I say flex start, if I say flex end, if I say stretch, something is familiar. Do you see? So what does justify content do? So if you take the phone and the view, and let's say flex direction is row, and so I have boxes here that are arranged, and let's say I have flex wrap disabled, then that means if I have thousands of boxes, then all of them are going to get arranged in this one single row. So either they can overflow or underflow, and when they underflow, this empty space in the first row of the main axis will be distributed among these boxes in this fashion. Flex start, flex end, center, space between, space around, space evenly. So the space in between these boxes can be controlled from the parent. Now when I switch on FlexWrap, what happens is, say I have hundreds and hundreds of boxes, so they are like overflowing. So when I switch on FlexWrap, these boxes now start forming rows, right? So let's say we have these 3 rows. Now consider this entire row as one single box. So you have row 1, we have row 2, and we have row 3. So these 3 rows are 3 boxes, and there is this empty space which can now be spread among these 3 boxes using align content. So here it was justify content, where along the single row, the empty space was being rationed in between these boxes, and now this empty space is being rationed in between these rows. So justify content, align content. So if I show the demo, so flex start, ours is flex direction is row. So if we change to column, flex end and center. And that concludes our tutorial on the Flexbox design. I mean, there are still other things like width and height we just discussed, right? We just give a width and height. It's very simple actually, very straightforward. Absolute and relative layout, and going deeper, yoga playground or nothing is there. So these two, width and height and absolute and relative layout, that stuff is actually not Flexbox, meaning the box is not flexing and it's not dynamically changing related to the parent. You're fixing it, absolute layout it is. You're saying that width is this much only, height is this much only. We are not doing flexible dance. So it's not part of Flexbox. So you can just go read about it. And as demo, I thought I'll give a hands-on walkthrough over this layout. So basically, if I say end screen, so basically I can design that same screen that we see in this picture. I mean, the colors are not that perfect and it's not like very aesthetic, but I've got the layout figured out. So whatever the layout is there in the demo picture, I'm able to get that exactly in the implementation. So if you like this video and if you want me to give a walkthrough of this particular design, please let me know in the comments and I'll make a video on that. I'll see you in the next video.